For our project, we tackled the problem of decentralized search on a Wikipedia network. We drew our inspiration from the Wiki game, and it's a fairly simple game. You are given a source article, and you have to find the shortest path to a certain target article. And you do that by navigating through links that are on the current article's Wikipedia page, and each of the clicks costs 1 step. And also, if you backtrack to the last article, then it costs you 1 step as well. The network is a small world-directed network with about 4,000 nodes, and it forms a strongly connected component, meaning that between every pair of articles, there is an actual path between them. And we can see that the shortest path between nodes is fairly small, with about three steps, and the clustering is also pretty high for the amount of nodes and edges.
For measures of success of our solutions, we decided upon using median of path lengths, average path lengths, and number of failures. As a primary measure of success, we used median of path lengths, since it is not affected by outliers. However, if we were to encounter an example where there would be an unusual high number of failures, this would also have to be taken into consideration.
So for our baseline algorithms, we used depth first and breadth first search. And for the uninformed depth first search, it kind of acts like a person which has no actual knowledge of the nodes, while informed depth first search takes into consideration the categories of the articles, meaning if the category of the final article is science, we would choose articles that are related to science. And for the uninformed breadth first search, we had an idea that it should kind of perform better than depth first search, since the solution is usually in the proximity of the current or the source node.
In our future solutions that we will present, we encountered a looping problem, meaning that when algorithm came to a certain node and decided upon traversing to another node, it started to jump between these nodes. And we solved this problem in 2 ways. The first was to remember all visited nodes and incorporated it into algorithms so that it wouldn't revisit those nodes. And the second solution that we came up with was to remember all previously traversed edges and instructed algorithm to not traverse them again. The idea here was that returning to a node via a different path can be beneficial, especially if this node was a hub. Our first decentralized search method was to look at node degrees. Here we use node degrees as some kind of prior knowledge that a human would have. And when algorithm arrived at some node, it first looked at its neighborhood. But if some of its neighbors were already visited, or if some of these neighbors were already visited via the same path, it excluded them. Next, the algorithm checked if a goal node was among its neighbors. If it was, we have found the path and we were done. If the goal node was not found among its neighbors, the algorithm picked the highest degree neighbor and moved to it and repeated the whole procedure.
Among the methods we considered for finding paths in Wiki games is also beam search. It uses breadth first search for building of its search tree. At each level, when we move to a new node, we look through its neighbors, and for later visiting, we only consider the ones that are promising. How promising they are is based on their similarity score, which we get from birth and cosine similarity. How many promising nodes we will visit at a later stage is determined by width denoted with beta. We tested for different beta values and found out that we get best results if we use our value 1. If, for example, for beta we would choose a value of affinity, we would just get basic breadth first search.
The results of all our experiments can be seen in the table on your screen. Using BERT with cosine similarity to extract context from node names proved to work the best. And surprisingly, do not revisit nodes looping policy also proved to work the best, even across all our experiments, which was kind of surprising since one would expect that allowing algorithm to revisit hubs and maybe taking a second best path would prove beneficial, but that was not the case.
So for our future work, we intend on expanding BERT with cosine similarity and by adding actual categories of the articles in addition to node names. We also intend to construct our own Wikipedia network with more data, and that way we can actually analyze the algorithms we implemented on that graph as well. And we can also follow how certain node properties and context changes through our wayfinding process.